There's really nothing quite like that feeling. You walk into a development meeting and they tell you you're building something completely new.
Oh, yeah.
Not fixing some old messy system, but just starting fresh. A true blank sheet moment.
It's the dream, right? The chance to do it right from the beginning.
It is. The excitement is huge. Trying out new tech, setting up the infrastructure exactly how you want it. But that excitement, it comes with this immediate pressure. You have to build that foundation before anyone even thinks about writing the first line of functional code. So our mission today is to do a deep dive into that crucial first step, specifically focusing on configuration management, or CM. How do you turn all that potential into a predictable reality? Okay, let's unpack this. What is configuration management really? In practice, it's a discipline, sure, but for you, the developer, CM means one thing, right?
Right.
If you rebuild the system today, tomorrow, or a year from now, with the exact same inputs, you get the exact same predictable result. It's all about consistency.
And that consistency is key. It's achieved because CM forces you to manage, well, way more than just your application source code.
So it's not just the code.
Not at all. When we talk about CM, we are defining, identifying, and controlling every single component that makes up your operational environment.
Every component.
Think about it. It's the libraries, the binaries your code depends on, sure, but it also goes out to config files, data schemas, the specific OS versions.
And now the infrastructure itself.
And crucially, the definitions of your infrastructure. We're talking network topologies, load balancers, how your cloud services are defined, all of it. It has to be recorded with its version, its relationships, its dependencies, all in a controlled repository. It's like the ultimate versioned inventory of your entire world.
That brings us right to our first segment, building that predictable foundation with automation. Because trying to manage all those relationships manually, even with a small team, would just be
Just catastrophe.
a complete catastrophe. In the old days, people tried with documentation, but documentation gets stale the second you hit save.
Precisely. And that's why modern CM tools are, well, they're mandatory now. Things like advanced version control systems, build pipelines, infrastructure as code platforms.
They automate the discipline.
They automate the discipline. When a change is proposed, let's say a change to a database schema, the tools don't just accept it. They enforce a defined, auditable process.
And that process captures who made the change, why they made it, and what its potential impact is across the whole system.
Right.
And the really critical part, the technical value, is they automatically validate that this new state is still compatible with everything else, long before it gets anywhere near production.
So the primary goal, so what here is just pure reliability and auditability.
Right.
The core objective is making sure a system can be reliably reproduced, audited, and importantly, rolled back to any previous state at any point in time. This is what we mean when we say single source of truth.
But hold on, isn't maintaining that single source of truth across code, infrastructure, and dependencies, isn't that massively resource intensive, or at least highly complex? What's the trade-off?
It is complex, yeah, but the trade-off is moving from reactive, expensive firefighting to proactive engineering.
Okay.
If you can't guarantee you can reproduce the environment that existed yesterday, you're basically operating on a wish and a prayer. And that costs way more in downtime and bug hunting than the investment in CM ever would.
That makes sense.
And what's more, modern CM, especially when it's driven by infrastructure as code, it actually shifts accountability.
Huh.
The system setup is just a configuration file, which is managed just like code in your VCS.
So a config error isn't on a person, it's on the process.
Exactly. The accountability for that error moves from an individual developer to the automated pipeline itself. If the pipeline succeeds, the environment has to be correct.
And that beautifully eliminates the developer's perennial nemesis, right? The infamous, it works on my machine problem.
John.
Because you're automating the propagation of those changes across dev, testing, staging, production. Everything is synced back to that single source of truth. If it works on your machine, it should work everywhere.
Exactly. And if we connect this to the bigger picture, CM provides that critical traceability you need for all your non-functional requirements.
So compliance, security.
All of it. That traceability is essential for compliance, for security checks, for quality assurance. It's the framework that turns what would otherwise be this complex, ever-changing collection of assets into a manageable, predictable, and auditable foundation for delivering reliable service.
So we've established CM is the discipline and the tools, VCS, IAC, they enforce it. Let's go back to that starting point, that blank sheet. You're in the conference room, ready to start the software journey. If CM manages consistency, what is the very first thing, the first piece of information that has to fall under its control? The answer is the requirement. I mean, if you're lucky enough to be involved from the very, very beginning, the first crucial step is defining and pinning down exactly what the software is going to do.
That requirement is the starting gun, for sure. But more importantly, it is the first managed artifact in your entire CM system.
The first thing you put into version control, basically.
Basically, yes. Whether it comes from a customer's statement of work or some internal product spec, that document has to be treated as the foundational blueprint.
And I'm guessing blueprint means it has to be detailed.
It has to be. It should specify every aspect of what the product will do, all its dependencies. And here's the crucial link to CM. This blueprint isn't just a high-level goal. It is what your testing team will use later to confirm the product performs correctly.
Right.
If you skip that and just bash on with the coding, you are setting up your testing and QA teams for absolute failure.
And that's such a common trap, isn't it?
Yeah.
Rushing to implementation. It's born of enthusiasm. Everyone wants to see code running right away.
Yeah.
But without a documented requirement, how do you even scope the product? You lose traceability before you've even started.
Which raises an important question for you, the listener. When you don't have a requirement, who is the final arbiter of correctness?
Who decides when it's done?
Who decides? If the requirement is just verbal, I guarantee you'll get immediate scope creep and chaos. The testing team needs a concrete, versioned, and documented requirement to confirm functionality. It is the very first component that requires version control.
Okay, so we have this foundational blueprint, the requirement. But let's get real about software development. As the project moves on, we have to be prepared for that requirement to evolve. Inevitable.
It always happens.
And that evolution, it often speeds up dramatically right after the customer or the stakeholders see the first working build.
Oh, absolutely. The first demo.
Yeah. That initial demo just triggers this fresh wave of excitement or a whole list of requests for new features they suddenly want added. And that, of course, impacts the timeline.
And this is where configuration management, specifically requirements management, becomes just paramount. Controlling that surge of feedback is the project manager's job, sure, but they execute that control using CM tools.
You can't just have requirements flying in through email.
No. Changes have to be integrated systematically, transparently. You cannot allow them to be added via email or some hallway conversation.
Well, we've got this list of initial requirements, and now we have this growing list of change requests, and they all need tracking. How does the CM discipline handle this with specific tools?
Well, the first essential CM tool you need is a system. It could be a dedicated requirements management system or even an advanced issue management platform to hold these requirements as atomic, separate elements and track every subsequent change request.
So this is how we impose structure on all that enthusiasm.
Exactly. The function of this system is to act as the database of the project's to-do list. Each requirement or change request is a separate numbered entry.
Numbered, okay.
And critically, each entry has an associated state: pending, approved, in development, in testing, complete. That structure guarantees traceability. If a bug pops up later, you can trace that piece of functionality directly back to the original numbered requirement it's supposed to fulfill.
And once the dev team understands those requirements, their priority, their state, they can start thinking strategically about how to actually build this thing, which often dictates how the project phases are structured.
Yes.
So instead of one big monolithic build, those requirement entries can be grouped up logically to define the phases of the project. Phase 1 could be essential infrastructure and core user login. Phase 2 implements the main business logic, and so on.
And that phasing is just a really powerful CM strategy. It lets you deliver a working product with limited but functional features at the end of each phase.
You get something to the customer's hands early.
You show it to them, you get their feedback, which, invariably means more change requests. But those requests are captured immediately back into the managed CM system. They get logged, prioritized, and scheduled for a future phase.
So it's a controlled cycle of feedback.
It's the difference between defining this massive 1,000-piece system on front and just hoping nothing changes versus defining, building, and delivering in controlled chunks. It allows that inevitable evolution of the product to happen in small, traceable, and controlled cycles. It ensures your code base never drifts away from the documented blueprint.
Here's where it gets really interesting. CM isn't just about managing the code, is it? It's about managing the intention behind the code.
That's a great way to put it.
Configuration management is the discipline for maintaining that consistency, that predictability throughout the system's life. The requirement is the essential blueprint, and the requirements management system is how you hold and version that blueprint, control its evolution, and make sure every single line of code can be justified.
Precisely. By keeping the requirements, the infrastructure definitions, and the source code all tied together in managed version systems, the team ensures that those inevitable changes and all that customer feedback are controlled, traceable, and integrated into the project timeline.
So they don't become chaos.
It prevents them from becoming those chaotic, project-derailing road bumps. Knowledge, in the context of software development, really is consistency, and consistency is managed through CM.
Which brings us to our final provocative thought for you to mull over as you approach your next blank sheet project. If the requirement is supposed to be this fixed blueprint, but we know for a fact it's going to evolve, and rapidly, the moment the customer sees the first build, what crucial configurations need to be absolutely locked down from day one? The foundation, the architecture, the tooling, versus what components must be explicitly designed from the start to be flexible and adaptive. The real discipline lies in knowing which parts of your configuration should never change and which parts must be built to welcome evolution.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.